Section 3.7, Equations of Lines in the Coordinate Plane. We're going to start with vocabulary. Number 1, an ordered pair describes the location of a point in a coordinate grid. That's true. Number 2, an ordered pair can be written as x-coordinate, comma, y-coordinate, or y-coordinate, comma, x-coordinate. Nope, just the first one. Number 3, an ordered pair for the origin is 0, 0. Yes. So our vocabulary builder, slope is rise over run. So you might also have remembered the formula to be y2 minus y1 over x2 minus x1. So let's use that vocabulary. Complete each statement with the appropriate word from the list. Use each word only once. So number 4, the blank of a hill made it difficult for bike riding. So that would be slope. Number 5, the driveway sloped down to the garage. And number 6, the sloping lawn led to the river. Draw a line from each word in column A to the corresponding part of speech in column B. So we've got linear is an adjective and a line is a noun. All right, problem number 1. We're going to be finding the slopes of lines. So for this got it, we're going to use the graph at the right. What is the slope of line A? Well, there's an awful lot of lines going on here, but line A is this one. So we want to find the slope of that line. Well, we want to pick 2 points that are on the line. So it looks like we've got the point 0.57 on the line and the 0.23 on the line. So those are the coordinates that we can use in our slope formula. So as it says in this chart, we're going to use 7 for y2, that goes in the numerator, and y1 is 3, the y-coordinate of the other point. 5 is the x-coordinate of the second point, and 2 is the x-coordinate of the first point. So when we subtract in the numerator, we get 4, subtract in the denominator, 3. So the slope is 4/3. The slope-intercept form of the equation of a line is what gets used most often when we're talking about slopes of lines. So that is the y equals mx plus b right here. The y equals mx plus b. The m is the slope and the b is the y-intercept. The point slope form is this other one. So the point slope form uses one point and the slope. So you need the x-coordinate and the y-coordinate of a point, and then also the slope. So y minus y1 equals mx minus x1. So the slope-intercept form gets used much more often than the point-slope form, but you do need to know how to do it, write equations of lines both ways. So let's go through these problems. Problem number 2 of the got it's here. Number 10, in what form is the given equation written? Well, that is in slope-intercept form. So we could write those words out. Slope-intercept form. Abbreviate a little bit there. Number 11, written as a fraction, the slope of this line is, so now I'm looking at this equation, y equals 3x minus 4. The slope is 3, but written as a fraction, 3/1. So 1 point on the graph is the y-intercept. And the y-intercept is given by the b in the y equals mx plus b. So in our line here, the y-intercept is 0, -4. So we're going to start by graphing at 0, -4. So put a point there, and then from that point we're going to move the slope. So our slope is 3 over 1, so we're going to move 3 units up and 1 unit to the right. So up 3, right 1 puts us there, and then we're going to graph y equals 3x minus 4 on the coordinate plane by drawing a line. So there is my line that connects those points. Please put arrows at the end of your line. All right, problem 3, writing equations of lines. So what is an equation of the line with slope -1/2 and y-intercept 2? So let's figure out what we know here. So the slope is -1/2. The y-intercept is 2. So we need to write the equation of a line. If we're given those two things, we should use y equals mx plus b. That is the slope-intercept form. So the equation is y equals -1/2 x plus 2. So hopefully these things are bringing back memories from your algebra days. So now we're going to have 2 points and write the equation of a line. So with this, it's often a good idea to use the point slope form. So you can see in the graph that we've got 2 points on our line. So we're going to use the point slope form. So let's have a look at see how they did that. So they're going to substitute in the x and y coordinates for the given point. So they picked one point to use. It looks like they used the point -2, -1, and the slope is 6/5. So the slope goes in the m position, and the x and y coordinates go in the appropriate places in the formula. So then it's a matter of simplifying. When you've got two negatives next to each other, that changes to addition. So these are the justification steps for the algebra. Oftentimes you leave the equation in that form, the point slope form, but sometimes you switch it back to the y equals mx plus b form. Just kind of depends on the directions. Okay, so this next one says use the two equations for the line shown above. Write the equations in slope-intercept form and compare them. What do you conclude? So number 18, this first equation, we're going to convert that over to slope-intercept form. So the first thing that we're going to do is use the distributive property to distribute that 6/5 into both terms in the parentheses. So y minus 5 equals 6/5 x minus 18/5. Then we're going to add 5 to the other side. But because I have a fraction here, 5 is equivalent to 25 over 5. So I'm going to add that to 18. And so together that makes 7/5. So the rest of my equation, y equals 6/5 x plus the 7/5. All right, the second equation, same thing. We're going to distribute our 6/5 and subtract the 1. So let's start by writing what happens when we distribute. So 6/5 x plus 12/5. So this time we're going to be subtracting the 1 on the left-hand side, but I'm going to write it as 5/5 so that I have a common denominator, so I can combine my 12/5 minus 5/5, and that gives me 7/5. So this simplifies to be y equals 6/5 x plus 7/5. So what are we noticing about these two equations? So we're going to underline the correct word to complete the sentence. So the two equations are the same. So choosing the point -2, -1 gives the same equation as choosing 3, 5. So both of them are equivalent. All right, and question 5 here, we're writing equations of horizontal and vertical lines. So true or false? Well, the question is, what are the equations for the horizontal and vertical lines through the point 4, -3? So we're going to write true or false. Number 20, every point on a horizontal line through 4, -3 has a y-coordinate of -3. That's true. So we're talking about the horizontal line for that one. Number 21, the equation of a vertical line through 4, -3 is y equals -3. No, that's not, because a y equals line is horizontal. And 22, the equation of a vertical line through 4, -3 is x equals 4. And yes, that's true. So let's go ahead and graph these lines. So the point 4, -3 is down here, and a horizontal line through that point goes this way. And a vertical line through that point goes this way. So that's what they look like on the graph. So a vertical equation is an x equals number, and the horizontal is y equals. So for our equations here, the horizontal line is y equals -3, and the vertical line is x equals 4. All right, let's do the lesson check. Okay, in this last section, a classmate found the slope of the line passing through the point 8, -2 and 8, 10 as shown at the right. Describe your classmate's error and then find the correct slope of the line passing through the given points. So let's look and see what they did. They subtracted 8s in the numerator and 10 minus -2 in the denominator. Well, it looks like they put the x-coordinates in the numerator and the y-coordinates in the denominator, and it should be the other way around. So we could say that slope is rise over run. Not the other way around. Okay, so to find the slope correctly, we're going to subtract the y-coordinates in the numerator. So we'll start with -2. Doesn't matter which one you start with, as long as you're consistent with your coordinates. So -2 minus 10, and then 8 minus 8. So if you did it the other way around, 10 minus -2 over 8 minus 8, you would get the same thing. Because both of them end up dividing by 0. So whether you get a positive 12 on the top or a negative 12 on the top, you're dividing by 0 in both cases. So the slope for this line is undefined. So you need to have memorized the point slope form and the slope intercept form.